Hi all, this is Jiten Krishna and welcome to back our yet another YouTube video. And today we are going to discuss about dynamic memory allocation. Before starting to the video or jumping into our topic, let me introduce myself. I'm a PSc Data Science graduate from Hindustan University. And if you have any further queries or clarifications after this video, just get in touch with me using my official mail ID displayed here. And before delaying further, let's jump into our topic. Okay, let's start with an example. Let's suppose a Starbucks is coming to our company and asking they need a website or they need an application to store their customer data. So what's the problem is that simply creating an interface and all is simply easy, but the task is that they generate lots of data and we need to store it in a specific way and it does not exceed or it does not match their living. Like one day, suppose 3 customers will get. So getting 3 customers or taking 3 spaces is enough. Sometimes on holidays or public holidays, like in special events, Valentine's Day, like days, the customer incoming or the number of customers coming to a shop will increase drastically, like 100 or 150. So we cannot predict or we cannot actually assign a value how much customers are gonna come a day. So as a simple logic, what if we use array here? But array is not a well-defined logic, right? Suppose consider that if you initialize an array for 150 in this case, in day 1 only 3 customers came. So rest 147 space become worthless or it is wasted. So what if you use array here again? Suppose the next day on day 2, suppose 200 or 1000 customers came. So what should we do that? Only 150 storage spaces are left there. So what is the issue? Array cannot accommodate that number of spaces. And next possibility is that while assigning this array, we need a linear storage, or we actually need a linear type of memory allocation. That is not a optimum case in computer memory allocation. The mini system has many files over time and it is continuously deleted and copied at random locations. So getting a linear data structure is not that much of an easy task. To understand this, let me give you an easy example. Suppose you have a friend group of 5 members and you went into a theater, but you cannot find a 5 linear seats there, or your 5 friends cannot sit there together. So what should we do here? What is the solution? How can we solve this? There comes the concept in computer science called, or data structure called, dynamic memory allocation. The concept is very simple. It is the ability of a program to request and release memory during runtime. That means dynamically they are asking and for memory location each time or each the cases, adapting to its needs. This contracts the static allocation where memory is fixed at the compile time. The memory is allocated during the compilation or the running. The benefits of this type of accommodation is that easy flexible. You cannot simply predict this number of customers came, right? So that's the easy part. It can accommodate data structure of varying sizes or growing or shrinking data, avoiding memory wastage or crashes due to insufficient or excess allocation. And next thing is, of course, efficiency. The memory used only when needed and reducing overall program footprint. I think this point is clear to you. And if you have any doubts, again, I am telling, if you need any clarification, just get in touch with me. But is it a fairy tale of data structure? No, it has its potential drawbacks. Some of them are potential memory leaks. If we allocate memory during the runtime, we are responsible for deallocating this. But if we forgot to deallocate them, cause memory leaks and unreleased allocated memory accumulates, leading to memory exhaustion and tracking and delocation or freeing or deleting are essential and should be done. Next thing is fragmentation. Repeated allocation and deallocation of can leave scattered unused memory blocks, increasing likelihood of allocation failure due to insufficient contiguous space. Techniques like memory compactation can mitigate this. Another is dynamic memory architecture. I'm not explaining that here. We need another day and another topic for that. So just take a quick glance at it and let's jump into another. We learned what is the basic concept about dynamic memory allocation. Now let's deep dive into dynamic memory allocation and its types. Some of the applications that is used in data structure are simply linked list, circular linked list, tree, stack, and queue. Here we are going to learn about singly linked list in detail, but you can glance at the structure of tree data structure and circular linked list, stack, queue here. Like now, let's deep dive into our main topic, singly linked list. Singly linked list actually operates using a data term called node. What is a node? Node contains of two parts. One is data part and other is linked part. So what does that mean? Suppose a customer came and they ordered about $45 worth of goods and we store that data. Along with that data, we store another part called linked part, and that carries the address of next data or next memory location we are going to assign our next variable. Suppose here we are going to see 45 is our data and its address is 1000, and along with that 45 we store an 2000, which is nothing but the address of the next data variable. We actually store only the address of first customer, that is 1000. That is called head. Whereas if you went from head to first customer, it also have the data of first customer. Then it goes to link part. It directs our compiler to the next node, which contains another data part and link part, containing the second data or data about the second customer or second segment, etc. Also the address to the next block. This continues on the fashion till the last node. And at the last node, the data link will be there and also address will be there. But over the link part, it is termed as null to know that this is the last node. And if another node comes in, the address of that node is copied here. In case of circular linked list, this address will always be the header. That makes the structure in a circular part. Now let's little more into our fashion. Let's go into our programming part. This is a simple C program for the implementation of linked list in C. First, we call hash include stdio.h, which means standard input and output operator for getting input and publishing it. Next, we call hash include stdlib.h. This is used for allocating dynamically, for allocating and deallocating the memory type. Next, we are going to define a function that can store our node. Node means you have seen here, this is a node. This is a node. And node has a data part and node has a pointer variable, which is the link part. This is not the definition of the C program. Struct is a data type in C that has named as node. And of course, we need just one variable, so we are declaring it here itself. Next one is we are creating a function for creating a new node. For creating a new node, we just need a data. Here we take a data with just a in data. So we can also create any other nodes with multiple data in this, but this thing, that is the link part, is a must thing. And we are declaring the node pointer as create node as the function, and create node takes the input in data, and node is the structure we defined here with the address to the variable new node equal to node star alloc malloc size of node. Here the size will be in, so 4 gigabytes will be 4 bytes will be allocated to node, new node, the variable new node. And if the new node equal to none, to check the memory allocation fail, that means if the new node is null, so the memory is not allocated at that space, we just return the null. Else we are gonna jump into new data equal to new data. That means the new data and data into our data that is defined here, and new data next equal will be updated as null. That means the last node here. And return the new node. And the insertion at the end of the list. To print the node, we use void. That means we are printing, that's why we use void here. Print list node the head. We just need the address of the head. Then we are gonna get the address of the next variables. While temp not equal to none, until the pointer reaches the null variable, we have to continue this. Printf for printing a int value, we got temp data. Temp is the header, and data in the header node is passed here. Then the temp is updated as the next. Next is nothing but the linked part of the node. Link part of the node. Link part of the next node. And at the last, we are gonna print null. Here we are not gonna get the input from the user, just defined 10, 20, 30 as insert at n, the function we called, and print list. And let's check our function. This is our output. 10 is stored first, then it transferred to 20 and 30, and last the null. So I guess our problem is solved here. So guys, our problem is solved here. I guess the problem is solved here. Like now we can create or start preparing our software or the program we required for Starbucks by dynamically allocating space for our data storage using single linked list with a user interface and other components, like you can guess. And thank you for keeping hearing me for this long, and keep this milkshake for staying for this long.